Hello students. Uh, Previously we have discussed the data to be collected for the fine aggregate as well as coarse aggregate. We should go through the specific gravity evaluation. So, and as well as the specific gravity of cement. So we have discussed this all. Now we are heading toward the design procedure. Uh, The minimum strength can be estimated by average design strength either by using standard deviation and can use coefficient of variation. Then to find the water cement ratio from the strength point of view from table 2, we will going to show the table 2, and also find the water cement ratio from the durability point of view by table 3. So in this the minimum strength uh, has to be known or should be evaluated by different statistical procedures, and that are the standard deviation and the coefficient of variation. Then obviously water cement ratio is again a big challenge to be known. So in the code of American Standard, American Concrete Institute, we have tables which we are going to show you. So in this we have the average compressive strength of 28 days, and corresponding to that we have water cement ratio, and we have both type of concretes, that are non-air entrained concretes and air entrained concretes. And we have discussed uh, what are air entrained concretes and what are non-air entrained concretes. And we can see that as the strength of concrete is reducing, the air water cement ratio is increasing with the decrease in the strength. So this is again the table from American Concrete Institute code of 211.1 1991. Now we will discuss the table 3, which is dependent, which is again giving a relationship between the water cement ratio and the durability conditions. So durability, as we know, that it varies with the exposure of the concrete with different natural environmental agents, that is fresh water, brackish or seawater, and again with different weather conditions we have different durability requirements, and for corresponding to the different durability requirements we have the water cement ratio, as we can see, and minimum design strength or low density aggregate concrete in megapascal. This is also being given, so we can find out the different minimum design strength according to the exposure conditions by the given code. That is, it has been also been mentioned in ACI 318. It is also an American code, which is one of the most practiced nowadays in USA. Then select maximum size of aggregate to be used. In regular fashion, we must know that in RCC work, we go for 20 mm of aggregate size, and for pre-stressed concrete, 10 mm of aggregate size are used. This 20 mm, as we know that is due to the grid which is developed to give strength by steel bars. These are longitudinal bars. These may be temperature reinforcement, or so for that concrete work we must have the aggregate size which should be not less than not greater than 20 mm. So we go restrict ourselves for RCC works. It may be the shear walls, it may be the reinforced foundations where we need a lot of small aggregate size. As in pre-stressed concrete, we also go for the small size and quite smaller than the RCC wall. In terms of workability, we have also a table which actually governs the water cement ratio in a concrete mix. So that will be shown in table 4. This is a table 4. This is again ACI 211.1, and we have shared this information from Shetty. It is the author of a book based on concrete technology. So we have range of slump, and corresponding to those slump values, uh, we have the utilities and the different structural components, that is reinforced foundation, plain footing, beams and reinforced concrete walls. So the we should choose the slump value, and then we will forward it to the next level, that is the water cement ratio. So the total water presence in kilogram per meter cube of concrete can be known by table 5. Now we are heading towards to know the water content or water presence in the concrete, and that will be shown in table 5 corresponding to the slump and maximum aggregate size. Table 5 gives the approximate amount of accidentally entrapped air and non-entrapped concrete. This is the table by, again, this is by the American Concrete Institute, and we have the different workability conditions, and corresponding to workability is actually being uh, uh, measured by the slump values. So slump values actually gives us the amount of water content in kilogram per meter cube for different type of concrete, that is for non-air entering concretes, and with corresponding to the aggregate size, and that ranges to 150 mm aggregate size. And here we have the slump values, and we can find out the water content in kilogram per meter cube by this table. Amount of cement can be computed by dividing the total water content by the water cement ratio. So we can find out the amount of cement easily by dividing the water content with the water cement ratio. In table 1, the bulk volume of dry roaded coarse aggregate per unit volume of concrete should be selected to determine the maximum size of coarse aggregate and fineness modulus of fine aggregates. So this can be done. We have discussed in the previous video about the table 1, where we have the uh, fineness modulus, and corresponding to that fineness modulus we have the bulk volume of dry roaded coarse aggregates per unit volume of concrete. And the weight of coarse aggregate per meter cube of concrete can be calculated by multiplying the bulk volume with bulk density. So obviously when we have the bulk density, so this will be in terms of kilonewton per meter cube, and when the meter cube will be divided by meter cube, it will cancel and it will give the unit weight, and it will give the weight of the coarse aggregate. The solid volume of coarse aggregate uh, in 1 meter cube of concrete can be calculated by knowing the specific gravity of coarse aggregate. We know that specific gravity, what is specific gravity? It is actually the ratio of the particular uh, weight, particular weight of a material with respect to the same weight per unit volume of water. So per unit volume of uh, particular commodity is actually the weight per unit volume, which is divided by the unit weight of water, which gives the specific gravity. The volume of cement, water and volume of air can be calculated in 1 meter cube. That is, it will again be same. If we can find out the coarse aggregate, we can find out these values as per the specific gravity if we know about them. And to determine the volume of sand, the volume of cement and coarse aggregate, water and entrapped air by subtracting the by the total volume of concrete. So volume of sand हम पता कर सकते हैं कब, जब हम सीमेंट का वॉल्यूम, कोर्स एग्रीगेट का वॉल्यूम, पानी और एंट्रैप्ड एयर का वॉल्यूम सब्ट्रैक्ट कर देंगे टोटल वॉल्यूम ऑफ कंक्रीट से, तो हमारा वॉल्यूम ऑफ सैंड आ जाएगा. इसी तरह द वेट ऑफ फाइन एग्रीगेट भी कैलकुलेट किया जा सकता है बाय डिटरमाइनिंग द प्रोडक्ट ऑफ वॉल्यूम ऑफ फाइन एग्रीगेट्स और उसकी स्पेसिफिक ग्रेविटी पता करके. तो एग्रीगेट्स को की स्पेसिफिक ग्रेविटी पता कर लेंगे फाइन एग्रीगेट की, तो वेट ऑफ द एग्रीगेट हम निकाल सकते हैं. तो दिस इज फॉर टुडे. थैंक यू.